Okay, let's go ahead and get started. Hello, everyone. Welcome. My name is Emily Kloss, and I work in communications at the National Renewable Energy Laboratory and support the Global Power Systems Transformation Consortium, also known as the GPST. Today's webinar is presented in partnership with the GPST and IEEE Standards Association and is titled New IEEE Standards Development for Distributed Energy Resources. So before we begin, I would like to go over a few housekeeping items with you all. The first is that this webinar is being recorded and it will be shared with attendees in the days following the event. As an attendee, you can expect to receive a follow-up email with a link to the recording, resources shared during today's session, and also the presentation deck from today's event. You will be automatically muted upon joining and throughout the webinar. If you would like to add comments, share input, or share introductions, we encourage you to please use the chat feature. If you would like to ask questions to our presenters at any point during the session, please use the Q&A function, and this can be found on the bottom of your Zoom toolbar at the bottom of your screen. And we encourage you to please ask questions at any point during the session. We do have time carved out at the end of the webinar for Q&A, so ask your questions at any point, and we'll be sure to address them at the end of the event. If you're having technical issues, please use the chat feature to message me, Emily Kloss, and I will be happy to help you. You can adjust your audio through the audio settings, but if you're having any issues, you can dial in and listen by phone, and all of this information can be found in your registration confirmation email. And lastly, we do have a survey that will launch when the webinar ends. We really appreciate any feedback that you can give us. Your feedback helps us gauge interest in who would like to join working groups, the quality of the presentation content, and also how we can improve these events in the future. Okay, next, I would love to introduce our speakers for today's event. First, we have Mamadou Jiang, who is an engineer for Dominion Energy and also the chair of the IEEE standard P1547. We have Jithinder Anandan, who is an engineer/scientist on the DER integration team at EPRI, and he's also the chair of IEEE standard P1547.10. And then we also have Mark Sierra, who is a principal at Power Innovation and the chair of Standards Coordinating Committee number 21. Okay, and with that, I would love to kick it over to Mark Sierra, who will introduce GPST, give an overview of IEEE standards, and also give an overview of today's webinar. Mark, over to you.
Okay, thanks, Emily. Go to the next slide. The agenda for today is principally to review two of the interconnection standards projects that are getting underway. The first one listed is the 1547 revision, which is the standard for interconnection to the distribution network, and Mamadou Jiang, who's the chair of that project, will be reviewing it. 1547.10 is a completely new area in part of the 1547 family, titled Recommended Practice for DER Gateway Platforms, and that'll be presented by that working group chair, Jithinder Anandan. I'll go through some takeaways, and then we'll have a good amount of time for Q&A. So next slide. I just wanted to highlight that this is sponsored by, and I'm very active in the Global Power Systems Transformation Consortium. And that's an effort of a large group of companies from many parts of the world to really facilitate the transformation and eliminate the blocks to dramatic transformation. And they're approaching it on a holistic view, dealing with operator requirements, workforce development. IEEE is leading the effort regarding technology adoption, and then there is work going on open data and tools. So that's an opportunity for you to participate. We'll give you that information at the end. Next slide. This is a rough, simplified org chart of the IEEE Standards Association. And Emily mentioned that I'm the chair of SCC 21. That's a standards committee. And that function is to listen to the industry and stakeholders and administer developing projects that end up being standards. The mechanisms we use on the bottom row is study groups, which is usually a 6-month-long project, which resulted in some of these projects, working groups, which are approved by the standards board. And both of these projects you're going to hear today are approved and moving forward. And there's other functions which we don't need to talk about. Move next slide. I think it's important to note as we look at IEEE standards and documents that there's a difference in the title and the nomenclature and the emphasis. Standards are documents that specify mandatory requirements, and the first project you hear about today, IEEE 1547, is a standard that uses the word shall in recommendations. Recommended practice is documents with procedures are preferred, are presented, and the wording is should. And 1547.10, the standards project you'll hear about next, is in that category. And we also produce quite a number of guides that provide information on how to apply the standards. Next slide. Okay, and I just want to emphasize that standards are important. They provide a consensus view of requirements and guidelines from the industry and other stakeholders. It's important to establish common terminology and frameworks so that as we have different aspects of these standards, everybody involved is using the same terminology. And over time, as these standards get developed, they lead to modularity in the implementation of the solutions. And that really helps frame the design rules for any industry moving forward. And there's lots of great examples listed in the references below. Let's move on. Next slide. I think we're good. All right.
Okay, thank you, Mark. Next, we will have Mamadou Jiang, who will present on IEEE 1547 Interconnection Standard Series.
Good morning, everyone. Emily, can you hear me okay?
Yep, we can hear you.
Thank you again, everyone, for joining this webinar. We really appreciate your time and your attention. I will be presenting a little bit about the one particular interconnection standard, IEEE 1547, and its standard series. As you all probably know, 1547 is a national standard here in the US. It became a national standard since around 2005, when it was cited in the US Federal Energy Policy Act under Section 1254. Since then, it has been widely adopted in many states here in America, but also around the world, where a lot of countries have expressed interest or about to adopt the standard. That standard also is being used by a lot of utilities commissions for interconnection rules and procedures, and also by other rural cooperatives and anyone else who has some particular interest in determining or figuring out how to interconnect the DER, which we call as the distributed energy resources, to the electric power system. Throughout the presentation, you will hear a lot about those terms DER or EPS, which again stand for electric power system. On the next slide, I will go over a little bit some of the different standards that are attached to 1547. IEEE 1547 is actually more than a standard. It also has different series of standards and guide and recommended practice, like Mark Sierra has mentioned briefly earlier, that are meant to help properly interconnect and integrate DER with the electric power system. So collectively, those standard guide and recommended practice under 1547 try to provide a cohesive set of requirements and recommended practice and guidance for addressing how to standardize the interconnection of DER to the electric power system. So some of those include 1547.3 that deals with cybersecurity, 1547.4 that deals with the island system, which we call nowadays microgrid, but also other standards related to energy storage, such as 1547.9, which is actually a guide and a recommended practice which we will be discussing a little later throughout this conversation. Now, next, I wanted to kind of dive a little deep into the standard that I believe a lot of you are here to kind of listen and learn about. So it's the standard 1547-2018. So 1547-2018 is actually the main standard for the interconnection and interoperability of DER with the electric power system. There's been a lot of challenges to actually go from what we have right now in 1547-2018 and 1547, the previous 1547, which is the 1547-2003. Previously, as you can see in this graph, the standard used to be focused mostly on distribution system aspect. But the fact of the matter is that distribution is connected to the transmission. So there's a need to actually worry about, or at least pay attention to, the impact any distributed generation, which we used to call, instead of DER, the impact that it can have on the bulk power system. So 1547-2018 get into those different aspects, and also goes beyond interconnection system, but it looks into the DER as a whole, how some specification may have significant impact on safety and reliability. It also get into something beyond that equipment listing, being how do you verify at the plant level? You may test an equipment that's a DER on a lab or individually, but you need to also worry about at the plant level, at the system level, how that can be impacting the system. Again, I can go on and on with on some of the new changes that we implemented as a team from 1547-2003 to 1547-2018. Among those, again, 1547-2018 has introduced different control functions, 11 of them, 60 parameters and more, a lot of variable adjustable parameter value, voltage categories such as category A and B, and disturbance rightful categories such as category 1, 2, 3. Again, just to name a few. Now, with that being said, you will all notice that a lot of the changes that went through between 2003 standard, 2003 and 1547-2018, make a lot of introduce a lot of items that can be challenging or found to be challenging in terms of application and trying to meet those requirements, both for users, developers, manufacturers. So which is the reason why that the standard committee under SCC 21 and the leadership team started the process of revising the interconnection guide, which is P1547.2, back in 2018. So I want to go over a little bit why this is important, why we needed to update the interconnection guide, which is 1547.2. So essentially what the guide does is it provides a lot of technical background, a lot of information on why we changed some parameters, added some more variable and description and requirement. What are the thought process behind that? So the idea is the document will hopefully help authorities having jurisdiction, so public utilities commissions, and anyone who has the need to understand why some of the requirements in the 1547-2018 standard, and how to enhance or help the grid as it was meant in the standard. All of those are discussed in the guide and as shown in the scope here in this slide. So I am the secretary for this P1547.2, and I believe when the guide will be out, which we are expecting it to be sometime in 2023, it will provide a lot of value to everyone, all stakeholders, and help them better understand and enhance their understanding of the standard 1547-2018. To continue on the guide, what it addresses, again, there's a lot of concepts that have been introduced in 1547-2018, something like I mentioned earlier, the authorities having jurisdiction, what are their role, what they could be doing to help keep the system safe and reliable. There's also a lot of requirement. I mentioned some for controlling the voltage, reactive power, different capabilities requirement, and also introduce a lot of items. Again, I'm not going to go through all of it, but again, just naming a few of the items that the guide, 1547.2, is attempting to address, hopefully with the goal of helping everyone, any stakeholder, understand how to apply the new standard. Now, finally, with respect to that too, the guide is also addressing communication, cybersecurity, how you do the testing and why testing is being done, and how do you apply the requirement, where those requirements should be applied. Should it be what we call of the POC, point of electrical connection, or should it be the point of common coupling? So all of those are addressed in the guide, and I believe it's going to be wonderful resources for everyone and all stakeholders. Next, I want to shift gear a little bit to kind of discuss another guide that was just published this year, which is IEEE 1547.9. As you all know, nowadays energy storage systems have become very predominant. Why? Because we experiencing a lot of increase in penetration of DER. A lot of those DER are intermittent, so which means that we need to find a way to reduce the impact associated with the intermittency of those DER. So again, the leadership team saw the need to put together a guide, hopefully that will help people to understand how the 1547-2018 standard applies to energy storage connecting to the power system. So again, some information for you, hopefully that will be helpful. The scope of the guide, again, is trying to help any users, any stakeholder understand how to apply the 1547-2018 to the standard. It also discuss any item that's not really discussed in 1547-2018 because it could be or could have been out of scope. Those include, as shown in this slide, how state of charge and some items like grid support modes such as Vol4, how does it apply to battery energy storage, which may or may not be able to bring additional functionalities not really described in the standard. How about V2G? We see a lot of electric vehicles coming into the market. Those electric vehicles have the capability of storing energy, but that energy could be, if everything is done properly, be able to be used and to supply loads or push power into the power system. How does it apply? How does the 1547 standard could potentially apply to that? And what about interoperability? How about testing? How do you test it? How do you apply? So again, a lot of things that were not really addressed in 1547-2018 that the guide has provided some kind of guidance for users and or stakeholders. With that in mind, this takes us to the key subject for today's webinar, the revision of the 1547-2018 standard. So I mentioned previously that there's a lot of items that were added to the new standard 1547-2018. We learn about energy storage and so how it could be challenging to apply the guide, 1547-2018 standard to energy storage. We also learn about other technology coming up. Again, some people will mention grid following inverter. How those apply to this? How does the standard apply to those? And plus, we had 4 years of experience since 2018 applying the standard, trying to implement those requirements. One example of those is how, for instance, some right requirement were touching some tripping requirement associated with zone of disturbances during normal operation of the power system. So that prompted several years ago, back in 2020, an amendment to the 1547-2018 standard. Again, we learn a lot of things that now we believe is the time to apply it to a new revision of the standard and hopefully address other items that were discovered. For instance, while trying to create testing requirement through UL 1741 for testing and verifying the compliance to the IEEE 1547 standard, just to name a few. And the next slide actually will go over briefly what process we went through to kind of come up with what we need to do a full revision of the standard. So as Mark mentioned previously, we were approved a few years ago to form a study group that looked at what are the different foundations, what are the requirements, what are the items that we need to look at for full revision of the standard. So that study group really was very helpful and provided guidance on important revision items and with the help from 7 different sponsors, which I will be noting later in the next slide. So essentially, this led to the approval of the PAR, the project authorization request, for us to create a 1547-2018 standard revision working group, which I am the chair, as noted earlier by Emily. So right now we have assembled a team. We're ready to start the revision of the 1547-2018 standard, and also establishing leads for different subgroups. The plan is just like I mentioned previously, to incorporate some of the learning and lessons learned over the last 4 years, and some of the items that we thought would be helpful to add to the 1547 main standard, which is the current standard, from 1547.9 and 1547.3, which deal with cybersecurity. The plan is just to start in early 2023. Right now, we have scheduled a kickoff meeting that will occur jointly with the Joint Technical Committee meeting of IEEE Power System Related Committee in Jacksonville, Florida. So that will be early in 2023. And the next slide shows again the kickoff meeting will be on January 9, and I invite everyone participating today to come and join that kickoff meeting and provide your guidance spot on some of the proposals that we have and the items that we put together through the study group that we believe are key in revising the standard 1547-2018. This is a list of some of the joint sponsored standard committees. 21 again. The chair is Mark Sarah here with us. The Power Electric Society, the Power Energy Society Transmission and Distribution Committee, the Communication Society and Power Line Communication Standard, the Energy Development and Power Generation Committee, the Electric Machinery, the Power System Communication Cybersecurity, and the PSRC, the Power System, are all joint sponsors for this revision of the 1547-2018 standard. Finally, just wanted to do a quick takeaway for all of you. As I discussed previously, there have been a lot of changes in standard that we think are critical, are good reason for us to revise the standard and hopefully to help the community and everyone design the system or prepare the system to properly integrate with the power system and while maintaining the safety and reliability and it being interoperable power system. Those include the revision of the guide, the 1547.3 cybersecurity guide, and the 1547.9. We also learn a lot from the 2800 standard, which is the equivalent of the 1547 standard, but for the transmission. And that's something that I probably should have noted earlier. 1547 is a distribution standard. If you're looking for a similar equivalent, you probably have to turn to 2800 standard. The 2800 standard has a lot of good items that were discussed and that we believe potentially could be put into the new revision to the 1547 2018 standard. Those include some technology changes. I mentioned earlier grid forming versus grid following inverters. How about interoperability? What did we learn from the past years? What other impact and issues that we've learned that need to be addressed in the standard? That's the goal, some of the few goals that we hopefully will be able to address with the revision of the 1547-2018 standard. And with that, I will say thank you all for your attention, and I will turn to my colleague attendant for a discussion of P1547.10. Thank you.
Thanks, Mamadou. We'll now hear from Jithinder Anandan, who will present on recommended practices for DER gateway platforms.
All right. Can you confirm if you can hear me okay, Emily?
Yep, we can hear you.
Hi, good morning, everyone. This is Jitendra Anandan from Electric Power Research Institute. I'm the working group chair for this newly approved IEEE project called P1547.10, which is the recommended practices for DER gateway platforms. So the main sponsor for this project is the SEC 21, Standards Coordination Committee 21. And we have got the approvals from NESCOM and IEEE SA standard boards early this summer to launch this project. Mark and Mamadou talked about earlier about the different IEEE standard classifications. And this one, 1547.10, it's going to be a recommended practice, which uses assured language. The reason we chose this to be a recommended practice is because this is relatively a new technology. There's a lot of emerging concepts here in this space. So making it a standard would have some constraints on the innovation in this space. And also, we wanted this 1547.10 to be a driver to develop the support in communication standards like 2030.5 and also DNP3 and other protocols. So we thought recommended practice could be the right fit for this project. So before I talk about P1547.10, I would like to take a moment to talk about DER gateways in general. Some of you might be very familiar with this concept. Some of you might be somewhat new to this concept. The DER gateway is basically a local on-site platform that houses logics and functions that are valuable to the utility. There are three aspects to the DER gateway. The first one is a distributed intelligence, the grid edge intelligence. What do I mean by grid edge intelligence? It's functions like, fail-safe operation. What does the DER must do when it loses communication to upstream managing entity? It's functions like scheduling, schedules that can be pushed from a centralized DERMS to grid edge so that they take the responsibility of operating the schedule to the DERs. It's functions like, alarms, events, or other functions like detection of unexpected DER settings change at the DER site, and so many other functions. Those can be put into the category of grid edge intelligence. The second one is communication interoperability. So we all know that different DERs speak different protocols. Even in 1547, 2018, there are three protocols that are called out for DER communication. So there needs to exist a platform which translates the protocol that the DER speaks to the protocol that the utility communications speak. And we believe Gateway could be the perfect platform for housing this protocol translation. And finally, cybersecurity. Utilities want to should be able to talk to only the DERs that are trusted and verified, and also securely. So in cybersecurity, you can have functions like transport layer security for, application layer security, or role-based access controls, or functions like even TPMs, trusted protocol modules for hardware security on board to prevent any hacking of the system. So all these would go into the cybersecurity. So these are the three aspects of the DER gateway, and we believe it's the missing link or the most overlooked component in the DER integration space currently. Why do I say that? For that, I'll go to standards like even 15. Let's take 1547 2018, or you can even consider other communication standards like CSIP, for example, which is Common Smart Inverter Profile. All these standards show these network adapters or gateways in their architecture. But none of these standards actually have any specifications or requirements laid out in their standards. And this is done intentionally because, one, to give flexibility to both utility and also to DER manufacturers. Utility in terms of, so that they can choose their own type of communication system or network to manage the DERs. DER manufacturers so that they can focus on their core competencies instead of having to step toes into communication technologies. Another reason is the lifespan of these DERs are usually 10, 20, 30 years. But if you look at the communication technologies, they are evolving every few years in the market. So by not specifying these requirements in the standards, they give flexibility again to utilities and manufacturers to adopt to emerging technologies in the market. And finally, if you were to put all this grid edge intelligence and cybersecurity within the DER, it just makes interconnection and interoperability much harder. So next, I would like to talk about some of the functions of a gateway, so, the things that I just covered earlier. And DER gateway is not a completely new technology or a concept. We have always had some form of a gateway, especially at big DER plants. But it has been in the form of RTU or RTAC, which has been used for some basic functions like, just to keep an eye on the DER site, just to monitor the site or to collect telemetry from the DER. But we feel this platform is underutilized and can be expanded into a number of applications that I'm showing to the right of the screen. So all these colorful boxes are basically each application or function in a gateway. And these fit into, again, the three categories that I mentioned earlier in the grid edge intelligence or communication or cybersecurity. Maybe I'll just give a couple, one or two examples here. Loss of master and reversion to defaults is basically fail-safe operation. It's basically the gateways take the role of putting the DER into fail-safe mode when it detects that it has lost communication to the upstream managing entity. And these settings can be exchanged, between the managing entity and the gateway when the communication was good. And scheduling, of course, I mentioned, centralized schedules that can be pushed to the grid edge so that there are no frequent communication between germs and the DER through the network. That also saves bandwidth. And on so many other functions that I'm showing here, but I'm not going to go into the details of each. These are some functions that we had identified earlier or prior in a EPRI-led project, which is also a working group with a number of utilities. And we believe this work that we did will serve as a base or reference for this 1547.10, and we'll be developing many other functions and applications like the ones that are shown in the figure. So coming back to 1547.10, what is the scope? What do we intend to cover in this recommended practice? So this document, it's going to first have clear definitions of what a gateway is, what are the different forms of gateway, what a local gateway can do, what a remote gateway can do, and also have a specification, not just the functional specifications that I talked earlier, but also some hardware specifications or software specifications, operating systems. What is the recommended firmware? What is the environmental environmental specifications like, voltage or, the operating weather temperature of these platforms. All those are also specified on top of the functional and cyber secure applications. So what is this going to address? We believe that this is the first of its kind standard in the industry for the gateway. We don't have one yet especially for gateway. And what it's going to provide is going to provide a menu of applications that utilities and the manufacturers can choose from for their needs and use cases. And it will have detailed requirements for each of these functions. So we believe the standard will enable utilities that are deploying DERMS and other DER integration systems to integrate DER with grid edge intelligence, while DERs do their focus on their core competencies of to make the interoperability and interconnection simpler. So to talk a little about the schedule, so we got all the approvals for this part. We'd like to kickstart along with the 1547/2018 revision in the second week of January in Jacksonville, Florida. And I also want to take time to acknowledge the sponsors and co-sponsors of the standard, which is Standards Coordination Committee 21, and also have other IEEE technical committees, which is Transmission and Distribution, the PLC, Power Line Communications, also have EDPG, PSCC, and PSRCC jointly sponsoring this effort. And this working group is going to be open to all stakeholders from DER vendors, DER communication system providers, aggregators, gateway providers, utilities, grid operators, also academia, or can participate in this working group. So it will be a 2-long-year activity starting in early 2023. We are hoping to publish the standard document by end of 2024. So that brings to the end of my presentation. With that, I'll turn it back to Mark for the key webinar takeaways.
Okay. Let's go to the next slide, which is the content. There we go. So this is kind of a repeat of what Mamadou discussed, but I wanted to do a little bit more detail on some of these conclusions. We are going through quite a number of changes underway, and that's really based on listening to the industry and the stakeholders. The two standards we reviewed today, the 1547 revision and 1547.10, were the result of study groups and industry dialogue that indicated a need, number one, to revise 1547/2018, which was published 4 years before we got the new project approved, much less time than the normal 10-year cycle that IEEE requires for standards development. And that's because we listened and we see some opportunity to clarify and update requirements. And as an undone, just reviewed 1547.10, that's a new opportunity for the industry to become more efficient and more modular and standardized, illustrating the benefits of standards. I did want to highlight in the second bullet that we talked about 1547.9 that was approved earlier this year. That's going to allow energy storage requirements to be added to what are included in 1547, such as bidirectionality, a fast frequency response and some things that may be vague. It's intended to clarify and gets into specific opportunities for application of energy storage. The 1547.2 is a really important guideline. It's been a long project. It's an outstanding document. I've seen a preview of it, and we're expecting it to be published by the first quarter of 2023. We're finalizing the comment resolution from the ballot process, and there's a possibility it may be approved this year, but it looks like first quarter 2023. And just keep your eyes open for that, because that's a really useful document for anybody practicing an interconnection with the grid. And about the same time, we have 1547.3, which is a guide for cybersecurity of DER systems. Another outstanding product is coming shortly, and I'll really look forward to seeing the industry reaction to that. And I would expect cybersecurity is something we'll continually see woven into the standards, or quick turnaround revision of standards. And then I also did want to emphasize, as far as interconnection, to the 2800 standard, which was published on Earth Day of 2022, was really a great accomplishment, and it focuses on inverter-based resources connected to the transmission system. And there's an active project, 2800.2, that focuses on the verification and test procedures. That's a very active project, and I find that it's I learn a lot participating in that working group. The real focus is on large-scale solar and wind projects, and it's really going to make a big impact on the industry. So I wanted to make sure you are aware that we've got the transmission requirements spelled out. We're evaluating other opportunities for standardization or guidelines, including grid forming inverters. We produced a white paper that compares the inverter and generation source types in kind of an objective fashion. But grid forming inverters, they've been around a while, and we need to evaluate how their implementation can be allowed and in the grid connected applications. More interoperability guides. I mentioned 1547.9 earlier. There's a extension of the interoperability requirements in 1547 listed for storage, such as capacity, storage, state of charge, things that are unique to energy storage. And I would expect a number of cybersecurity guides to continue to be developed in addition to 1547.3. All of these will have impact for verification and testing. So if you're involved in the industry, that's an opportunity to clarify what you need to do and who you can talk to verify that they're compliance to the standards. Let's go to the next slide. What are we doing on time? We're close. Let's see. I wanted to give you a takeaway if you're interested in participating in the standards projects. Mamadou and Jitender shared with you. If you go into IEEE My Project, this is the designation to get into the 1547 series. Currently, it's the Standards Board, SCC 21, and then the revision working group is the one that Mamadou reviewed, and it's 1547.10. So just so you're aware, sometimes difficult to view the codes they use in my project. I just noted that the SCC 21 is changing the reporting relationship, so there may be in early 2023 that may be showing that it's part of the Board of Governors instead of the Standards Board. You should be able to find it by clicking on 1547 and the right projects will come up. I put this link in, so this is a descriptive script on how to actually sign up and share your interests in the projects. Well, I really thank you for taking the time to review this. We'd love to get your feedback and continue the dialogue on these important new standards developments. With that, we could open a discussion on the Q&A. Emily, I'll let you drive how the pace is.
Hey, Mark, so if you open up the Q&A box, yeah, all the questions should be there.
Okay. Some of the ones that came up in this meeting, I'm going to start with just want to get to the top. There's a few I tried to answer. Let me start off with a question that does the IEEE 1547 standard consider bidirectionality between the DER and the grid? And my initial reaction is that I'm most familiar with 1547.9 that begins to deal with that, and it's being evaluated as an element of 1547.4. But I'm maybe ask Mamadou to elaborate on that if you've got any other input for the bidirectional power flow. I think my sense is that 1547.9 didn't just deal with exporting power, but it also dealt with the importing of power for battery charging. So please correct me if I'm wrong.
Yep. Thank you, Mark, for the question. I was actually going to ask more clarification on that question, on meaning what is the context behind that question, in the sense that when you look at 1547, if you're talking about bidirectionality, this is not really where you should look at it unless you remain battery energy storage and how bidirectionality of those energy storage can be within the scope of 1547. So that's another question. That's the two questions I will see in that. The first one that I mentioned, any DER parallel of the electric power system or the grid for more than 100 milliseconds typically is within the scope of 1547 standard. So it doesn't matter if they're exporting or not, but the paralleling time applies to it. Now, with the standard, the way it's written, if you are not paralleling for 100 milliseconds, but you are connecting to a network system. I don't know if you know the term of network or a network system, what it means, then it doesn't matter what your paralleling requirement, how long you parallel, 1547 applies to you. That's one of the odd cases. Now, to come back with the energy storage, there are aspects of the energy storage that when you look at it, because it's parallel with the grid, even if it can be used as a load, which is, I'm assuming, that's the directionality question that the attendee is mentioning. Yes, 1547 energy storage applies to 1547. As a matter of fact, when you read the scope and purpose, it clearly says it applies to any DER, and energy storage is defined as being a DER, because energy storage has the capability of storing energy and also taking that energy stored and pushing that power to the power system and the grid. And hopefully that's helpful. Again, just having a difficulty understanding the context for that question.
Yeah. Thanks, Mamadou. Another question relates to 1547.10. It's kind of a multi-layered question, but what forms will a DER gateway take for the residential scale? Something like a meter collar was a question. Jitender, do you want to try to elaborate on that?
Sure. We are seeing lots of forms of gateways. It's Some are just purely software based that could be included into the the DER firmware, or some that could be integrated as part of the AMI meter systems. We are actually doing involved in a DOE project with E10, where they are implementing some of these gateway applications in a smart meter controller that they call for residential or premise level DERs. Or it could be, a standalone DER by itself, like in the form of a Raspberry Pi or a BeagleBone that talks to the DER locally.
Okay, thanks. There was a question I was asked earlier on by Ahmed, and I goofed up the answer and sent it to him only in the chat, but it was related to how do grid standards, like we just discussed, relate to grid codes. My immediate answer was that the 1547 standard sets the technical requirements. 1547.1 describes the test and verification requirements. And as that's being developed, the equipment standards are developed, like UL 1741 for inverters. And at that point, once there's clarity in the actual requirements, the regulations get developed. And I think Brian made a very effective answer to the group, and that local laws and rules are set by states, PUCs, and utilities are what generally gets referred to as grid codes. I wanted the group to be aware that the Global Power Systems Consortium is working on and has some dialogue on international web codes, including those, or grid codes, including those in the US. It's not a simple answer where they come from, what kind of track what they are has taken a lot of resources up, but take a look at that, globalpst.org. All right. So another question for Anandan, if I see a product list to 1547.10, does it mean it follows all recommendations, considering that this is a standard of recommendations rather than requirements? And I think
sure. Thanks, Mark, for the question.
Thank you.
Yeah, as I mentioned earlier, this is a recommended practice, and it's not a standard like the 1547/2018, because the gateways are relatively young and still emerging technology solutions, and making it a standard could adversely constrain the room for innovation. So, and also listing making the gateway as a standard will also require adoption by use of certifications or listings, as in the case of like 1547.1 and UL 1741 for inverters. So it's not requirements like the 1547 main standard. It's recommendation, and also the intent is to provide the recommendations for all the applications, and we believe that it serves as a menu of options that the utilities and the DR manufacturers can choose from to implement as per their use case and their requirements.
Okay, thank you. There's one more question on the Q&A I'd like to have our group take. Grid forming was mentioned now several times as new technology that drives future testing verification practices. But, for example, 2800 highlights that grid forming is still to be considered as emerging technology. 2800 is not explicitly specifying grid forming capabilities and services, which working group with an IEEE is expected to come up with more tangible specs in the area of grid forming. I'll answer this one. This actually is we formed a study group to look at revising 1547.4, which is a guideline, a recommended practice that deals with islanded systems or microgrids, some people say. And the study group's going to determine whether or not we revise 1547.4 and update it, and should that include specifications for grid forming inverters. And if it doesn't, there may be a new working group formed to deal with that. Even though grid forming inverters have been used in UPSs and other applications for a long time, they haven't been used in grid connected applications. And an example, I would say, simplifying it, that a utility protection engineer, if they see a system that can form an island, most would react that they would require extensive system protection to isolate that system. And we need to work through what requirements have to be to reverse that thinking. And so it's, anyways, and thank you for asking the question. I thought it was very good. Mamadou or Jitendra, do you have anything to add?
Yeah, this is Mamadou, Mark. Yeah, I just wanted to add that this was a great question. I just wanted to remind that IEEE 1547 try to be technology neutral. So we try not to just specifically target a technology or not, but we will generally address items that will be useful to the stakeholders so that they can better integrate and ensure that DER interoperate with the power system properly. So grid forming inverter, this is definitely an emerging technology. A lot of utilities, including mine, are looking into piloting some of those, including with battery energy storage system. But again, there's a lot more to learn about what's the best way to integrate those DER or to design them so that they properly interoperate with the power system. And Mark mentioned DAT4, which is the guide for island system, essentially what you guys call microgrid. We see that grid forming inverter to be very prevalent in microgrid system or island system. How will it be able to interact properly with while staying interconnected to the grid, not in an island? That's a good question. That's what we trying to figure out with expert and any participant that have the knowledge and the know-how. What's the best way to figure out to determine the requirement that will ensure a proper interoperability of the power system. That's what I wanted to add, Mark, to what you said. Thank you.
There's one other point I wanted to make that Mamadou prompted, is that the SC21 did have a study group on grid forming inverters, and they produced a white paper, which is available. You should be able to find it on our SCC21 website. And please, if you can't find it, please contact us. And we'd be happy to provide you that. And that compares grid forming, grid following inverters, and rotating machines, and the history and the reason for the standards that exist. I think that completes the Q&A.
Hi, Mark. We actually got one more question from Kimbrel. She said, where can I find more details about the project you mentioned with the DOE?
Sure. This is the project that was sponsored by CETO, and it's called Risk-Informed Hierarchical Control of Behind-the-Meter DERs. So the project is basically developing a real-time controller, a smart meter controller for the behind-the-meter DERs, such as solar and battery storage and EPRI is a partner of this in this project. We are providing standard communications like 2030.5 to be used for the meter controller. I will connect with you offline to to connect you to the PI or PM in Eaton after this meeting, where they'll be able to share more resources and document. I think we're still in budget period 2 of this project, so there's I think budget period 3 is the field demonstration, and we'll have a final report when the at the end of budget period 3, and that will be public online. But for now, I'll connect you with the PI at Eaton.
Great. We do have one other question that came through in the chat from Manuel. He said, will 1547 series cover FRT requirements for electric vehicles?
This is Mark. I believe there's a beginning of that discussion in 1547.9, which was just published, and there may be some other consideration of that as we look at revising 1547.4 or grid forming inverters. That's a very important question, and it's just we're trying to deal with it. And as Mamadou said, in a technology neutral way, because there may be many different technologies supporting it. But that's coming, and there is some discussion in 1547.9. Thank you. All right. So is that it, Emily? I think we got most of the questions.
Yep, it looks like that was all the questions.
All right.
Oh, I'm sorry. There's one other one from Lei, who said, where can I find more details about the January 2023 meeting in Jacksonville, Florida?
Well, I think there's published information on the overall event called the IEEE Power and Energy Society Joint Technical Meetings, and I think you go into the PES website, and there may be other direct login links, but that's the intention of the overall group meeting there.
Correct, Mark.
Okay.
Yeah, I was going to add that the JTC and Joint Technical Committee meeting of the PSRC will have some information in there how to sign up. That should be happening sometime late November, early December for you all to sign up. And but the other thing that we're trying to do, which is the reason why Emily and I will put that posting on the chat. If you express your interest by creating a free account, or if you have an account at IEEE My Project, you will be put in a listing where we can broadcast that to everyone that has signed up with more information on the kickoff meeting. Again, this is just one venue, but there's other venues for us to provide you more information. And we'll try also to publish it on social media and everywhere just to let people know. But it is correct. It will be January 9 in Jacksonville, Florida. What will mostly happen is during the day, we'll have the 1547 with 2018 revision during the day, and in the afternoon, we'll have the DAT 10 kickoff meeting. But the goal will be to, after that, start moving forward fully to establishing the work and the procedures and the subgroups for revising the 1547-2018 standard. And hopefully that's helpful.
Yeah. Thanks. Good question.
I just shared a link in the chat. I'm not sure if it's for IEEE. I'm not sure if it's directly for this meeting, but it looks like it's January in Jacksonville, and it has an overview of the event, and then I guess the registration link will be posted here.
Okay, I don't think they're not ready to go live, so I think we just need to stay tuned to that, and when the registration link comes on, you can sign up.
Correct, yes. They're not ready yet. The registration link is not ready to go live, correct?
So I think that's all we got. Emily?
I think so. Those were all the questions.
Okay. So, are we good to adjourn the webinar?
I think so. Thank you everyone for joining. As a reminder, we do have a survey that will launch when the webinar ends. We greatly appreciate your participation in that. And yeah, hope you all have a great rest of your day. Thank you very much.